Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. So in the last video, we already discussed about the generating functions part 1, that is the second order recurrence relation. Then coming to the part 2, that is the generating functions for third order recurrence relation. So how to find the solution, for the three order recurrence relation, third order recurrence relation. What is the solution of the recurrence relation? We can understand those things by considering some examples. Consider the first example. Solve an minus 6an minus 1 plus 12an minus 2 minus 8an minus 3 equal to 0 by using generating function. How many terms are there? There is a 3 terms, that is n minus 3. So n minus 2, then it is called as 2 order or second order recurrence relation. If it is n minus 3, then it is called as a third order recurrence relation. In case of third order, the procedure is same, but the number of terms and number of solutions are increased. Now consider the step number 1. So whatever the recurrence relation that has given, consider as a of x is equal to n equal to 0 to infinity an x to the power of 1. That is equation number 1. Next, multiply each term with equation number 1 by x to the power of n and take the summation from 3 to infinity. That means we have to start from the n term to n minus 3. That is n equal to 0 to 3 an x to the power of n minus 6 into sigma n equal to, second term is n minus 1 into x to the power of n, then 12 sigma n equal to 3 an minus 2 x to the power of n minus 8 into sigma n equal to 3 to infinity an minus 3 into x to the power of n is equal to 0. Then after that, replace each term with the corresponding sequence of term. Then we'll get so that is of x minus a naught minus a1x into a2x square. In the case of second order, we have to expand up to x, but in the case of third order, we have to expand up to x square. Minus 6x into of x minus a naught minus a1x plus 12x square of x minus a naught minus 8x cube into a of x. Now we need to separate the terms. Take a of x as common. In the first term, a of x 1 minus. The second term 6x ax means minus 6x. Third term 12x square into a of x means 12x square. Last term is 8x cube. Whatever the remaining term, this is a minus a naught. It goes to the right side, a naught plus a1x, then a2x square. Next, minus into minus, that is plus, it comes to the right side, 6a naught x, then a1x, that is 6a1x. Next, 12 minus 12x a naught, that comes to the right side, plus, then a of x equal to a naught plus a1x minus 6x a naught 12x square, 8x square minus a 6a1x plus 12a naught x square divided by 1 minus 6x plus 12x square minus 8x cube. Now we need to decompose the equation into fractional fractions. We'll get the equation as 1 minus 2x whole cube. That is the equation. What is the first term? A naught. Take x as common. A1 minus 6x, no, 6a naught. X square as common. A2 minus 6a1 plus 12a naught. Then we need to separate the terms. This is for a naught. Take the first constant as c1. For the second term, take the c2 as a constant. For x square, we need to take c3. So we need to decompose the equation. C1 by 1 minus 2x. So C1 by 1 minus 2x, C2 by 1 minus 2x square, C3 by 1 minus 2x cube. What is C1, C2, C3? Those are the constant values. Then find the solution. C1 into 1 minus 2x whole power minus 1. Then C2 1 minus 2x whole power minus 2. C3 1 minus 2x whole power minus 3. And after deriving the what is the generalized function? So that is 2x whole power n. This term becomes the c into n plus 1 because it is a power of minus 2 n plus 1 and n. Whereas the third term n plus 2 and n, that is 2x power n is common. This is the extra term, that is the combination of c of n plus 1 according to the formula, that is 1 minus x whole power minus n formula we have to apply. These are the terms we are going to get in the recurrence relation. Then after that c1 2 power n, c2 2 power n to n plus 1, then 2 power n. Then what is the formula for n plus 2 is n plus 2 into n plus 1 divided by 2, 2 power n x power n. Then after simplifying the expression c1 2 power n, c2 n plus 1 2 power n, c3 n plus 2 n plus 1 by 2 into 2 power n x to the power of n. Then what is the recurrence relation for an? c1 2 power n, c2 n plus 1 2 power n, c3 n plus 2 n plus 1 by 2 divided by 2 into 2 power n is the solution for the recurrence relation. So in the case of second order recurrence relation, we are going to find only two constants, that is c1 and c2 only. Whereas in the case of the third order recurrence relation, we need to find out c1, c2, c3 constant. Then we have to find the three solutions, that is so this is the third order, we have to find the solution for c1, c2, c3. So consider the one more example. Solve the recurrence relation an minus 9an minus 1 plus 26an minus 2 minus 24an minus 3. Here it is a minus equal to 0 for n greater than or equal to 3. And not only that, there are initial conditions are given, a0 equal to 0, a1 equal to 1, a2 equal to 10. What is the equation number 1? So whatever the recurrence relation that has given, consider equation number 1. What is step 2? Multiply each term by x to the power of n and take the summation from 3 to infinity. Why we need to consider from 3 to infinity? Because there is a 3 terms. N greater than or equal to 3 means we need to consider the 3 terms. Right? Step 2. Multiply each term by x power n and take the summation from 3 to infinity. First term an x to the power of n, second term n minus 1 x to the power of n, third term n minus 2 x to the power of n and n minus 3 x to the power of n. So each summation start from n equal to 3 to infinity. Now replace each infinite sum with the corresponding sequence of expression. We'll get a of x minus a0 minus a1x minus a2x square. Second term is 9x. Third term is 26x square, 24x cube. So these are the terms. Now we need to separate the terms. That is ax, a of x minus what is the equation? A of x minus 10x square. That is a2 value. A0 value is 0. Don't consider. In the place of a1 you have to substitute x minus 10x square minus 9x a of x. A0 value 0. In the place of a1 substitute x. a1 is 1 into x 6. Then 26x square. A of x minus 0 means that is 0 only. Minus 24x cube. A of x is equal to 0. Next, take a of x as common. First term 1 is there. Second term 9x is there. Third term 26x square is there. Fourth term 24x cube. What are the remaining terms? Minus x goes to right side. X plus 10x square. Minus plus, minus into minus plus 9x square goes to the right side. 9x square. Then we'll get, so what is 10x square minus 9x square is x square. X plus x square by 1 minus 9x minus 26x minus 24x. After deriving these values, we are going to get 1 minus 2x. So the first fraction is 1 by 2, second fraction is 1 by 3, third value is 1 by 4. That is, after substituting, we have to get the values. That is, C1, C2, C3 values are substituted. We'll get the first fraction is 3 by 2, second fraction is minus 4, third fraction is 5 by 2. So 3 by 2, take the summation 1 by 1 minus 2x whole power minus 1. That is 2 power n x power n. Minus 4 into 1 by 1 minus 3x, that is 3 power n x to the power of n. 5 by 2 into, here 5 by 2, 4 to the power of n x to the power of n. So after that we need to take a power n x power n sigma n equal to 0 to infinity. First term is 2 power n, take x power n is common because x power n is common in the three terms. Then take x power n as common. First term is 3 power n, 2 power n. Second term is 4 into 3 power n. Third term is 5 by 2 into 4 power n. What is the solution of recurrence relation? an equal to 3 by 2 into 2 power n minus second term is so 4 into 3 by 2, 3 power n plus 5 by 2 into 4 power n is the required solution for the recurrence relation. So what we have discussed up to now, what is meant by generating function, what is the third order recurrence relation, how to find the solution for the third order recurrence relation. We can understand both things with the help of the example. Thank you.